in the previous video we actually talked about the synchronized method where you use the clock SCL to actually send your SDA data for your I2C. Alright, so now we're going to introduce you with another method such that you don't need to use the SCL or the synchronizer. We can also use the asynchronous system where there will be no clock, alright, where you can also still send your data. Alright, so because without SCL you actually reduce one more wire. Alright, so because if you still remember your I2C, it is a 2-wire interface. Alright, SDA and SCL, and nonetheless you have a ground, so together you have a 3 wire. Alright, so if you have no SCL, alright, so we can further reduce it to a 2-wire system, only the ground and the SDA, okay, and all the data that you want to send. Alright, and therefore let's start off with the understanding of a asynchronous system where you have no clock or where you have no SCL or you don't have any SCL at all. Okay, so therefore in the traditional way of a asynchronous serial port, alright, we use the COM port, or I think it's the serial COM monitor. Alright, I think it's that one. Sorry, I don't think so. Okay, these are the COM port. Alright, where you put in your monitor. Normally you put your monitor, you put your computer, you connect with this. This is called a COM port. Alright, so you have a few pins. You see 1 pin, 2 pin, 3, 4, 5, 6, 7, 8, 9 pin. I don't know why 9 pin, but anyway, the old method of a traditional without any SCL serial port, which is what we will show you the COM port. Alright, so these are all the traditional old way, but nowadays we can use USB. Alright, and therefore we will connect this USB to wherever port you want, and then this port will connect to your monitor or whatever. So USB acts as a universal port, alright, to connect to your computer, and so this universal port can be connected to other stuff with its own heads. Alright, and you can connect to your COM port also, or things like that. I don't know, but at least you see something lah. Okay, so the USB itself is like also asynchronous serial port, so to speak, I think. Yeah. So how it works is that you transmit the data by separate packets. Alright, we're talking about bytes. So each of the packet is 1 byte. So 1 byte is one packet. So 1 packet inside got 8 bits. So it sends 8 bits by 8 bits, 1 byte by 1 byte, or 1 packet by 1 packet. Okay. So generally the understanding for the asynchronous without a clock is this thing over here. Okay, so how the pack is being sent is that in order to send 1 byte, this is 1 byte. Alright, this is 1 packet. Okay, you have 8 bit 1, 2, 3, 4, 5, 6, 7, 8 bit. Alright, so each of this 1 byte has 8 bit within itself. Alright, and it's being sent through a baud rate. Alright, this baud rate is your serial if you remember, your Arduino is a serial dot begin 9600. Alright, this tells you, or this implies to you, that you can actually use you can actually send to the maximum that you can send 9600 bits per second. Alright, so this is telling you that you can allow your Arduino to send 9600 bits per second. Or if you were to divide it by 8, you can send 1200 bytes per second. Okay, so you can send 1200 of this 1 packet per second, which is okay lah, not bad lah. Okay, I don't know how to determine which is good or which is bad, but anyway, at least you get a feel of the baud rate. Alright, and this baud rate is 2 to the power of 300. Sorry, my fault. If I type 2 to the power of 300, you'll go to like macam very big number. But anyway, it should be 300 times 2 to the power of something. Alright, if it's 2 to the power of 6, for example, you'll get 9600. Alright, sorry, you'll get equals to 19,200. Okay, if it's 300 times 2 to the power of 5, you'll get 9600 bits per second. Okay, so it depends on the power of your bits too. So I think this is 6 to the power of 6. I think you can send 5 bit at one time. I don't know. Alright, I just leave you to think about it lah. But anyway, the rate itself is usually 300 times the power of 2 something. Alright, so 300 times 2 to the power of 5, you get 9600. So this is just the meaning of it. Sorry, you get 9600 over, yeah. So therefore this is the thing lah, alright. For a non-clock, so you have no clock at all, alright, your transmitter and your receiver must be configured manually for the same rate. So you can receive and transmit at the same rate. Because if you transmit differently from your receiver, then you may actually do do different jobs at once, which is not very good. So you want a synchronized system such that you although it's synchronized, but you don't need a clock. Alright, therefore this process is called the asynchronous, which we have been talking about, because we don't need the clock. So how this asynchronous works finally, because I have talked about so many things already, is this. Alright, so same thing, the line is held at logic 1. So your Arduino itself is gonna be always high. Okay, it's always gonna be high. Alright, held at logic 1. Okay, so when it's idle, then the Arduino itself will always send a logic 1 all over. Alright, as long as when the circuit is closed, alright, then this thing over here will be removed. Alright, and this will tell the Arduino itself that the device has taken data from your or your Arduino is taking data with your device, or your device is receiving data from your Arduino. Things like that. You can receive from your device can receive data from Arduino, or you can also send data to the Arduino. So this two method all at once, if you still remember, is the full duplex. If it's sent one time by one time, or in other words, you receive first and then you send back, then it's called half duplex. But in our case, I think we are dealing with full duplex. Alright, so it's way better than half duplex because it's more efficient. You can send and receive at the same time. To start transmission, you also need so this thing at first is always high, and in order to tell the device that okay, time to receive some information from Arduino, alright, then I'm gonna set up my start bit as 0 first. So the first particular system is gonna be 0. Alright, so this particular bit, this is 1 bit already. Alright, and we set this 1 bit as 0. So the first bit, no matter what, has to be equals to 0. Alright, so this tells the system that okay, let's start. So once you start already, you can start to send your signal. So this particular portion over here is the packet that you want to send, right? This packet comes from here, right? You see? This thing over here is being placed within here. You see it's a blue color line. Okay? So this 1 byte, alright, 1 byte packet is gonna be sent to your, it's gonna be ready to send. Alright, so a transition from 1 to 0 tells you that let's start. Alright, and after you finish your system, a stop bit of 1, so over here you start to have a stop bit. So it tells the system that okay, let's stop already, and then after that it will continue to actually close down and then take in another set of bytes, things like that. So this part over here tells you let's stop, and then over here it tells you that okay, let's start again. Alright, and take in another series of bytes and things like that. Okay, so it's the same thing as your SCL, but in a way that they actually do this in this manner lah. Okay, it's very similar, because if you remember the SCL one, also you need to set the bit to be 0 first if you want to start. If you want to end, alright, over here this is the with the SCL one. Alright, this is the previous part. So this over here is your synchronized one, alright, with a clock. So over here when you start, alright, it becomes 0, and then when you end, it also becomes 0, telling the system to feedback to Arduino that okay, let's stop. Alright, so that one is for the for the clock one. So without the clock, alright, this is not low, because if with the clock, as you can see, you require a logic of low over here to indicate that we have stopped. Alright, over here we can set it as the stop bit is actually set as a high, then after that it continue to go down, which indicates that you're gonna have another start bit to coming up, and then things like that going on. Okay, I hope that this is somewhat a little bit clear. Alright, so for a full picture, if you didn't send any data, if your SDA, this line, this bus is a SDA bus or wire, alright, this is SDA. If it's never connected to any device, it is float high, alright, which is at the start logic always high. As and when if happen that if one of the circuit, is closed switch. Alright, your analog is gonna, not why I kept saying analog, this Arduino, your Arduino is gonna send all your information all the way to the device. So you'll connect to the device. Okay, so when you connect to the device, the start bit over here at this point will go to 0. Alright, so your device over here will go to 0, indicating that, okay, Arduino, please send me your data. So over here, Arduino start to send your data. Blah 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 blah. So after sending all the data into this device, alright, so I finished my receiving. Alright, over at this device, it will send back to Arduino stating that, so you have sent a 1 bit high, alright, to the Arduino that, okay, it's time to stop, I don't need you anymore. Alright, so over here, alright, it starts to go down, or it should actually go all the way high. So if it's go all the way high, this means what? Alright, this means that the Arduino is gonna float back to high, so it's able to receive another devices again. Alright, so if for example it's like this. Alright, so if this is the case, then this means that the Arduino has float high back. Alright, if it's like this means that it's gonna prepare to receive another byte. So you're gonna continue. So this thing over here tells the Arduino again, please send me the next byte. Alright, so the Arduino will say, okay, I send you the next byte now. So you'll send you the next byte again. After that, then the device will tell Arduino again, okay, it's time to stop, and things like that. Alright, so along the period of time, alright, all these things happens in half a period. Alright, then check whether, I think this one you can read yourself. Okay, so half a period means what? So if you remember, one signal, for example, a sine wave, half a period is this thing. Alright, or this thing. Alright, half of the period. This full one is 1 period. Correct? From the start to the end, this is 1 period. Diabo, right? So therefore over here, this is something like this. So this part over here is the high, and then over here this part is the, at this point this part is the low. Alright, so this is a half period. So over at this side is telling us that you wait half a period and then check that the start bit is equals to 0. So over here you check that whether is this start bit. So over here at this particular point, this is half of the period. Alright, I should have said that this part. Okay, so this line to here is half a period. Alright, so you check whether the start bit is equals to 0. Alright, so once you check already, alright, you're gonna wait one more period. So over here is like this. So graphically something like this. Okay, so this part is the low part. Alright, and then this part is the high part. Alright, so over here you're gonna wait 1 period. So this portion over here is 1 period, and then you read a bit 0. The next start comes in. Alright, so I think this is the first bit coming in already. I think, yeah, this is the, over here this is the first bit. Alright, so after which you can continue to send in the bit. So wait 1 period and then read bit 1. So for each of the period you read bit by 1. So for each of the period, this is 1 period, 1 period, 1 period, 1 period. So 1 period represents 1 bit. Okay, so you're gonna read remaining of the bits. After that, before you end, you're gonna wait 1 more period over here, and then you check that the stop bit is equals to 1. Alright, over here this is the stop bit. Actually I should say that over here you need to know that this is the stop bit. Sometimes the stop bit may be lag a bit. So over here you may see, the stop bit may actually appear to be here, and then it starts to stop, and then things like that. So you need to know this little stuff. Alright, so therefore you will want your error to be 4% tolerable. Alright, so as I say, this supposedly this place is where your stop bit, alright, is equals to 1, has to be over here. But because for some error that may occur, you may have the stop bit to be delayed over here. Alright, so in case of, instead of here, it stops from here. It stops at here. Okay, so we want it to be 4% tolerable. Alright, otherwise you have a problem. Alright, so therefore you need to resynchronize your system to get a next start transition. So therefore your upload will fail. So you request to the system in your computer telling that, okay, please send me again your data. So you're gonna remove all the stuff if there's error, and then you're gonna tell the system that please send me a new data with the same thing. Then you'll just repeat again and things like that. Alright, hope that this is pretty clear. Therefore, this asynchronizing communication can be, although it's a hard word, but can also be used by computing using a software. And you just remember, if you use your Arduino or whatever to code, when you use a software to code your data sending or whatever, this is called a big banging, right? Because you're just coding your stuff. So this method is called big banging. Alright, happen that you forgot or whatever. Alright, and therefore this big banging, if you were to code, you're gonna take in some memory for the microcontroller, because you're gonna occupy some of the microcontroller stuff. Alright, so therefore you actually slow down the baud rates. If you still remember, your baud rate is 9600 bits per second or whatever. So if you happen that you use your Arduino to code, you may actually take up maybe 2600 bits in order to code your this system to receive or whatever. Alright, so these processes are being coded out from programs. Alright, so you use 2600 of these bits to code your stuff, right, while the 7000 others is being used to actually transfer data and things like that. So therefore, these are the little stuff that you also need to understand. Alright, therefore because of coding inside your Arduino, you actually slow down your transfer rate. Alright, you actually slow down your thing. So if you have more system, then your Arduino is going to code more. You're going to take up more bits in order to sort out your data. So left over, you only have 4600, for example. Alright, so because 9600 minus 5000, you'll get left 4600. So you are able to only transfer your data using only 4600 bits per second. Alright, so you're going to slow down your system if you have more devices that is connected to it. Alright, so you have to be careful when you design your stuff. So your I2C actually itself has its built-in interfaces to actually handle serial data or your SDA communications. So therefore, you have a serial communications interface, SCI or SEC, or UART, this stuff. I think you need to memorize, because I think I saw it in the practice question. So you just need to know how these things are, actually to help you to handle synchronized signals, or to help you make your signal better, so that there will be lesser error, because as you know, we may have a certain errors that is coming out, so be careful of that. So therefore, in order to enhance your performance of your system, the I2C, alright, the I2C bus actually have interfaces of these two interfaces to help you sort things out better. Lastly, before I go, you may wonder, is I2C a synchronized or unsynchronized system? Or it's actually a synchronized system, but because sometimes other devices may not be synchronized, some devices may be asynchronized. So therefore, you have a universal asynchronous receiver. So you receive the asynchronous data and make it synchronized, and then tells your I2C that okay, it is synchronized now, so I can rearrange my stuff, things like that. So therefore, these are the purpose of my universal asynchronous stuff within itself. Alright, so I2C by default is a synchronized system, but it can help to unpack asynchronous data also. Okay, with all this two stuff lah, so to speak. Alright, so I hope that this is overall give you a full understanding of I2C. Alright, although I may not fully understand just yet, but anyway, I'll leave you to think about it. So in the next video, we'll talk briefly about how is your serial interface being implemented, because there are different power source. Alright, so see you there.